So, 1, 2. Honestly, guys, this might be the most important lesson in trig. Okay? This is being dead honest. Okay? This here, this trig functions, this right triangle trig, the relationships that we're going to talk about right now. If you don't remember anything from trig, this is what I need you to remember going forward. Okay? If you cannot remember these things, you're kind of going to be screwed going forward. Okay? Just being straight honest. That's why we could probably do lesson 1, 2 in 2 days. I'm probably going to split it up over 3 lessons because I really want to focus on this first part. Okay? So right here, trigonometry means the measurement of triangles. So right here is the triangle that kind of goes off of everything. It's the measurement of right triangles specifically. Okay, so this is a right triangle. If your reference angle is this one right here in your triangle, okay, I need you to memorize how this is set up. So obviously your hypotenuse is the side across from your right triangle, correct? Okay, that's straightforward. We've learned that back in algebra. The side that is touching that reference angle, here's my reference angle. The side that's touching it is your adjacent side. The side that doesn't touch it is the opposite side. Okay, it's just a simple thing. Now, why do I need you to memorize this picture? Well, that's where all of these guys come into play. Okay, so a trig function is basically a ratio. A sine of an angle is equal to a ratio in this case, and it's the ratio based on the proportions of the triangle. All right, you're just taking 2 or 3 things into account for this. So when you're looking at this, the relationship of sine of theta, the sine of your reference angle, is going to be your opposite over hypotenuse. So it's whatever your opposite side is over the hypotenuse. Okay, your cosine, the relationship or the ratio that goes with your cosine is going to be adjacent over hypotenuse. And your tangent is going to be opposite over hypotenuse. So those are the main 3. This part right here, so that triangle above, the adjacent, opposite, hypotenuse, if I say I need you to draw the reference triangle, you need to be able to write that down. Okay? And this part right here, the basic trig function, sine, cosine, and tangent, this is our standard. I need you to remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over hypotenuse. Way to remember this, SOHCAHTOA. All right, SOHCAHTOA is, everybody always says there's like the ancient Indian tribe, or it's not true. Okay, if you look it up, it's not true. But if you can remember the phrase SOHCAHTOA, so sine opposite over hypotenuse, cosine adjacent hypotenuse, toa, tangent opposite adjacent. Okay, just a little phrase to remember. The other one, there was another phrase. I don't remember what it was. Hypotenuse. Oh, sorry, adjacent. I wrote that wrong. Adjacent. My fault. My fault. My fault. My fault.
I was going to ask you why they're doing the same.
Yep. Adjacent. Adjacent. My bad. All right. So there we go. So if you remember SOHCAHTOA, I'm telling you guys, that triangle and these 3, opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. You remember SOHCAHTOA, you're in good shape. Now, SOHCAHTOA. Sine, opposite hypotenuse. Cosine adjacent hypotenuse. TOA, tangent opposite adjacent. Now, we struggled with this last year. We struggled with this last year, okay? It's SOHCAHTOA, not SOHCAHTOA. All right? We struggled with that last year. People wanted to remember SOHCAHTOA. So then that got them all screwed up. All right? So I'd say to them, all right, I'd be like, What's the sine? Oh, that's suck. No, that's not. What's tangent? Oh, that's toes. No. Okay? SOHCAHTOA, not suckatoe. SOHCAHTOA.
How many times have you said it? Now I'm gonna remember that.
It's gonna what? SOHCAHTOA is gonna be ingrained? Good. That's what I was going for. All right, SOHCAHTOA.
You got one, but those two are stuck on Sokotoa. He's got no idea what's going on.
Now, the big ones, like I said, sine, cosine, tangent. I need you to memorize these three. Now, these ones here, all right, these are kind of your secondary trig functions. Okay, these are your secondary ones. This is cosecant, secant, and cotangent. Okay, so these are your mains, these are your secondaries. All these are going to be inverses. So if you can remember sine, cosine, and tangent, have those memorized, you can make the other ones. Now, cosecant, and it's weird too. You would think cosecant would go with cosine, right? It's backwards. Okay, so cosecant goes with sine, secant goes with cosine. Because they're inverses, you invert the words as well. So cosecant is going to be the opposite of sine. So this would be hypotenuse over opposite. Okay, next one, secant would be hypotenuse over adjacent. And then cotangent is going to be adjacent over opposite. Now the nice part about these is you can get a very little bit of information about your triangle and you can come up with all 6 of these pretty quickly. All right, so let's do that once. And just a note, these are just all reciprocals of sine, cosine, tangent. Remember, SOHCAHTOA, right, Belinda? SOHCAHTOA. No sucking toes. SOHCAHTOA. All right. What? Sine, cosine, tangent. Okay. Good now? Sure? All right. So, I got 2 triangles up here. We're going to do the first one together, then I'm going to let you try the second one. So I'm going to give you some information. So here, that's going to be my reference angle. It's a right triangle. Say that side is 5, that side is 12. So we want to come up with the 6 values of the trig functions for this triangle. Now, looking at it first off, we have 2 of the sides, don't we? Okay. We need the third side. How can we find the third side? What's the law of triangles? It's probably the most famous. Guy with a funky name. There we go. Yep, Pythagorean theorem. So let's do it for a reminder. So the Pythagorean theorem is a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Okay, so I can use that here. So this would be 5 squared plus 12 squared equals c squared. So I'm looking at 25 plus 144 equals c squared, which would be what, 169. Square root both sides. C is going to be 13. Okay. So there's my 3 sides to my triangle. If I know 2, I can always find the third by the Pythagorean theorem. Good. All right. So, like I said, this is the angle we're using. That's my reference angle. All right. So from there, sine is going to be opposite over hypotenuse. So when I'm looking at this side here, which side is my opposite side? 5. Hypotenuse is 13. Okay, so the sine of theta in this guy would be 5 over 13. Cosine is adjacent over hypotenuse. What's my adjacent side? 12. So it would be 12 over hypotenuse, which is 13. And then lastly, tangent, opposite over adjacent. Opposite is 5. Adjacent is 12. Okay. Now, I'm not even going to really spend the time on it for cosecant, secant, and cotangent because I just have to flip each one of the first ones, correct? Okay, so cosecant is going to be 13 over 5. Secant is going to be 13 over 12. Cotangent is going to be 12 over 5. Questions on that one, guys? All right, on this next one, I don't know if I want to give you. I'll keep it easy. I'll keep this one easy, and then you want one a little harder. All right. All right. So here's your reference angle. 3, 1. You're missing that side. Now, I'll help you get the first side. Okay. So we're gonna have 1 squared plus x squared equals 3 squared. Okay, so 1 plus x squared equals 9. Take the 1 over, I have x squared equals 8. Square root both sides, so x is going to be 2 root 2, right? I don't want to take this to decimals because I'm going to be putting them in fractions anyway, right? So I can't have a decimal within a fraction. So this missing side would be 2 root 2. All right, now I'm going to give you a couple minutes. I want you to find the 6 values. So let's go over these 6 here. First one, it's not letting me open it. There we go, maybe. All right, so the first one, the sine. Sine is going to be opposite over hypotenuse. So what's that one going to be? 1/3. Good. Second one, cosine is adjacent over hypotenuse. So that's going to be 2 root 2 over 3. Good. Last one, tangent is opposite over adjacent, which is 1 over 2 root 2. Now, you asked about it. We got a little problem. Are we allowed to have a square root in the bottom? No, we can't. What I like to do, though, is definitely write this. Now, I want to get rid of that root 2, so multiply by root 2 over root 2. All right, that's how we simplify radicals. So now I'm left with root 2 over, it'd be 2 root 4, which is going to be just 4. Okay, so it'd be root 2 over 4. Now, I still like to write it down to start with because my cotangent is going to be the opposite of this guy. All right, so if I just, in my head, I can come up with root 2 over 4, but I like to write that down because that's what you're going to use reciprocal of anyway. All right, so the next one, cosecant is going to be what then? 3 over 1 or 3. You want to simplify them if you can. Okay. Secant is going to be 3 over 2 root 2. So now I need to simplify it. That's going to be 3 root 2 over 4. And then lastly, cotangent, we said it's going to be 2 root 2 over 1, or just 2 root 2. You all right with that, guys? All right, so that's how you find the trig values, the 6 trig values for a triangle. Now, we have a couple special triangles. All right, these special triangles are going to be used over and over and over and over again. All right, these are going to be the most common ones you have. A 45, 45, 90, and a 30, 60, 90. Okay, these would also be something that would probably be a good idea to memorize. You don't have to memorize all of these. Okay, you don't. I don't expect you to necessarily say, if I say to you, what's the cosine of 45 degrees? You don't necessarily have to have it or know it, but you should be able to construct both of these triangles and then figure them all out. Okay, so a 45, 45, 90 triangle, that is based off of both of these guys having a length of 1. Okay, then if I would use the Pythagorean theorem to find the third side, I'm going to have 1 squared plus 1 squared equals c squared. So that's going to be 2 square root of 2. So it's going to be square root of 2. Okay, so a 45, 45, 90 is going to have legs of 1 and 1, square root of 2. The sides have to be the same. It's an isosceles triangle because, if you remember, opposite angles, if you have opposite angles to opposite sides, if the angles are the same, the sides have to be the same and vice versa, if you remember that from geometry. Okay, so and then in this case, the sine of this, the sine of 45, is going to be 1 over root 2. Okay, so we'll just say that it doesn't matter which one. All right, so if that's my reference angle, that one's my 45. Sine of 45 degrees can be 1 over root 2 multiplied by root 2 over 2, root 2 over root 2. So the sine of 45 is going to be root 2 over 2. Okay, cosine of 45 degrees would be the same thing. Opposite over adjacent and adjacent over opposite over hypotenuse and adjacent over hypotenuse is the same thing. So that's going to be root 2 over 2 as well. And then the tangent, opposite over adjacent, would be 1 over 1 or 1. All right, then you could find the cosecant, secant, cotangent of that if you wanted to. You just reciprocate each one of those. All right. The second, the 45, 45, 90, that's the easiest one. It's straightforward. Okay. Second one, 30, 60, 90 triangle. It's a little bit tougher. So I'm going to put I'm going to make this my 60 degrees, make this my 30 degrees. Okay. Now one is twice as big as the other one. All right, in this case now, this side would be root 3. This side would be 1. This side would be 2. Every 30, 60, 90, it will have that same setup, same relationship. Okay. A lot of times people, when you're constructing this, the hardest thing to do is know where the root 3 and the 1 go. How big is root 3? If you put that in a calculator, what do you get? It's like 1.45. Okay, it's like 1.45. So that is bigger than this one, but still smaller than 2. Okay, now the way to remember where the root 3 and 1 go, root 3 is always touching the 30 degrees. So the 3 stay together. Okay, the other way you can remember is 60 degrees is across from root 3. Root 3 is bigger than 1. Okay? Now, for these relationships, all right, so the sine of 30 is going to be opposite over hypotenuse, so that's going to be 1/2. Cosine of 30 is going to be adjacent over hypotenuse, which is root 3 over 2. And then the tangent of 30 is going to be opposite over adjacent, so I'm looking at 1 over root 3 multiplied by root 3 over root 3, and it's just going to be root 3 over 3 after you simplify. So now I can use 60. I've switched things around. Now 60 is my reference angle. If it's 60 degrees, I'm going to have opposite over hypotenuse. Opposite is root 3. Hypotenuse is 2. Cosine of 60 is going to be adjacent, which is 1 over hypotenuse of 2. Tangent of 60 is going to be opposite over adjacent, which would be root 3 over 1 or just root 3. You guys with me on how I got those? Same relationships that we just did. All right, so Catella. On. Okay, what about on the second one? Uh-huh. Are you saying like here? Okay, why are they different? Okay, well, 60 is twice as big as 30, right? So 60 is twice as big as 30, they can't have the same relationships. All right, now then what we did, the first one, we just looked at 30, we looked at how everything was related to 30. So if 30 is my reference angle, this is my adjacent, this is my opposite, this is my hypotenuse. If I stand up here at 60, now this becomes my adjacent, this is my opposite, that's my hypotenuse. Is that what you're, all right? You just have to remember, you don't always use like the bottom number, okay? I have to, if I was using 30, I look at the relationship based off of 30. If I go to 60, the second set is sine of 60, cosine 60, tangent of 60, I gotta look at 60, look at the relationships based off of the 60-degree angle.
Would you ever ask about
No, you wouldn't do that. Okay. All right, so I just gave you a nice little chart, and like I said, our angles in our world are going to be based off of most likely multiples of 45, 30, and 60. That's why we have memorized these special triangles. Whenever we get into bigger numbers, those are the most common ones that we're going to hit. So here's just a little reference thing for you. 30 degrees, the sine of 30 is the same as pi over 6. That one's 1/2. I'm just going to fill this out as kind of a reference thing for you. We just did them above. All right, so I'm just copying them down from above. And I also put in the radian measure for that as well. Okay, the radian measure for 30 degrees is pi over 6, 45 is pi over 4, and 60 degrees is pi over 3. And we're just filling these in. We just found them above. Okay. All right, the next part here is reciprocal identities and quotient identities. All they really are is, what we already talked about. If you think about it, the sine and cosecant. Well, the sine is just, this kind of sine and cosecant are reciprocals of each other, correct? All right, so for instance here, I said the sine is opposite over hypotenuse, correct? And cosecant was hypotenuse over opposite, right? So if I do this, I have sine equals 1 over cosecant is hypotenuse over opposite. All I do is just flip it up and multiply the top by it, right? multiplied by the reciprocal. Okay, you're just going to get back to your opposite over hypotenuse. That's all these things are saying. All right, so you can use these to rewrite things if need be. Okay, quotient identity, same with this. Tangent is the same as sine over cosine. Cosine or cotangent is the same as cosine over sine. This would be a pretty good one to know. All right, well, sometimes when we get farther on, we'll have to rewrite things because more often than not, finding cosine or sine is easier than finding tangent. So you can rewrite it as one or the other. Okay, we're not going to use those a whole heck of a lot right this minute, but I just want to get them down, get them in your notes. All right, let's look at one more example, then we'll call it good for the day. Okay, let's look at this bottom example. So, given the sine of theta equals 2/5 and the cosine of theta equals root 21 over 5, find the value of the 6 trig functions. All right, so the 6 sine, cosine, tangent, and then I have cosecant, secant, and cotangent. Okay, so I want to find those 6 values. I already know 2 of them though, don't I? All right, I already know that the sine is 2 over 5, and I know that the cosine is root 21 over 5. Okay, so I got 2 ways I can do this. 1, I can do it algebraically. 2, I can do it with a picture. So let's look at it kind of both ways. Well, first off, if I look at this right now, I know the sine is 2/5. So what's the cosecant? Stick with me for a couple minutes. 5 over 2. I'll write you a pass if need be. All right. Secant is going to be 5 over root 21, right? Then I have to multiply by root 21 over root 21, which is going to give me 5 root 21 over over 21. The root goes away. Okay. And then lastly, I'm just kind of stuck now, right? Those are the easy ones. Now, we just said that tangent was the same as sine over cosine, correct? I just said that up above. It was sine over cosine. Sine is 2/5. Cosine is root 21 over 5. Well, if I reciprocate that up, the 5's are going to cancel, right? So that's going to leave me with 2 over root 21. So then I would simplify the radical, and I would have 2 root 21 over 21. So then cotangent, on the other way, I'm just going to come back to this guy right here. It would be root 21 over 2. Okay? The other way I could do this, just really quick, I could draw a triangle. Say this is my reference, this is my right angle. All right? So opposite over hypotenuse is sine. Opposite's 2, hypotenuse is 5. Cosine is adjacent over hypotenuse. Well, there I just created my triangle. I could go back through and do the opposite over adjacent and so on and so forth from that. Make sense, guys? All right. Have a good day. There will be an assignment up on this stuff.